For decades, the idea of bionic vision has been pure science fiction, right? The kind of thing you'd see in the movies. But what was once just a cool concept is now actually being engineered in labs. And the goal? It's not just to restore sight, but to completely redefine what it means to see. We're talking about a direct link between a computer and the human brain. So let's really dive in and see how this is all supposed to work. And this is really the big question, isn't it? It's the one that's driving this entire incredibly ambitious project. It forces you to think way beyond just medicine and into the world of human enhancement. We're not just asking, hey, can we fix blindness? We're asking, can we build a better reality? Okay, so before we jump into the wild future, we really have to understand the past. In the story of bionic vision, well, it starts with a device that offered a ton of hope, but also a pretty harsh lesson. So back in 2013, a device called the Argus 2 was truly revolutionary. Picture this. You've got a camera mounted on a pair of glasses. It captures whatever's in front of you. Then, a little processor converts that video into a super simple 60-pixel black and white image. And finally, an implant literally zaps that pattern directly onto your retina. This was the very first device of its kind to get FDA approval. A huge deal. And for a little while, it was honestly miraculous. You had people who had lived in total darkness for years who could suddenly see doorways or the outlines of other people. They could perceive light. There was one user, an archer, who was actually able to use his bionic retina to hit targets. It was a genuine breakthrough. It gave people a real second chance at a kind of sight. Yeah, but that dream didn't last. The company behind the Argus 2, a company called Second Sight, they ran into a massive problem. And it had nothing to do with whether their tech worked, and everything to do with money and the future. The problem was a simple and pretty brutal one: money. The device itself cost a staggering $150,000. But when you add in the surgery, the years of specialized rehab, you're looking at a total bill that's closer to $500,000. The company was just burning through cash, and by 2020, it had pretty much collapsed. And when the company went under, it took its patients down with it. People with these implants suddenly had zero support. There was one man, Ross, who couldn't get a critical MRI because nobody could confirm if the implant was safe to be around the magnets. Another guy, Jerome, the archer, his processor broke. And just like that, he was left with a useless chip in his eye and absolutely no one to call for help. This right here became the ghost in the machine for the whole industry. It's annoying when your phone becomes obsolete, right? But what happens when the hardware that's no longer supported is literally inside your eye? The failure of Argus 2 taught everyone a critical lesson. For this kind of tech to work long-term, it has to be sustainable, and maybe most importantly, it has to be upgradable. And that massive, painful lesson is exactly the problem that a company you've probably heard of is trying to solve. This is where Neuralink steps into the picture. They're not just trying to build a better version of the old tech, they're trying to solve the fundamental problems that made it fail in the first place. Their approach is, well, it's just orders of magnitude more ambitious. Just look at this comparison. The sheer scale of the leap is incredible. Argus 2 sat on the retina. Neuralink goes directly into the brain's visual cortex. Argus had 60 data channels. Think of it like 60 pixels. Neuralink's first device has over 1,000. But really, the two biggest game changers are these. It's fully wireless, and it is designed from day one to be upgraded. And all of this is possible because of a few key breakthroughs. Instead of using rigid needles, Neuralink uses these ultra-thin, flexible threads that are inserted by a custom surgical robot. And this robot is so precise, it can literally weave these threads into the brain while dodging blood vessels. The result is this high-bandwidth, wireless system that's completely invisible once it's implanted. And this chart, this just says it all. We're going from 60 pixels of information to over 1,000, and their next-gen chip is targeting over 16,000. That is the difference between seeing a blurry shape and potentially recognizing a face or reading large text. In this game, bandwidth is absolutely everything. And it is already changing lives. The first Neuralink product is actually called telepathy, and it lets people with paralysis control computers with just their thoughts. The first participant, a man named Nolan, who is a quadriplegic, now works a full day. He's learning new languages, and get this, he plays Mario Kart against other participants. He's regained a level of digital independence that was just completely impossible for him before. But controlling a cursor, that's just the beginning. That's the warm-up act. The next major goal is to apply this same brain-computer interface to vision with a project they're calling Blindsight. And this is where things start to sound like they are pulled straight out of a sci-fi novel. So the really crucial point about Blindsight is that it doesn't even need working eyes. It plans to send a video feed from a camera directly into the visual processing center of the brain, completely bypassing the eyes and the optic nerve. In theory, this could restore sight even to people who were born blind, people whose brains have never received a single signal from an optic nerve. And look, this isn't some far-off 50-year dream. Neuralink has laid out an incredibly aggressive public roadmap. They plan to implant their first Blindsight participant in 2026. That's just 2 years from now. And they're aiming for devices with over 25,000 channels by 2028. The pace here is just astonishing. And make no mistake, restoring function is only step one. The long-term vision here is enhancement. Musk has talked about things like seeing in different wavelengths, like infrared, or having a true augmented reality overlay right in your mind, and eventually creating a high-bandwidth link between our brains and AI, which would let us communicate at the speed of thought. So what we're witnessing is literally the birth of an entirely new field, neuroengineering. It promises to solve some of the most devastating injuries and diseases that affect the brain and spine. But with that incredible promise, it also raises some of the most profound questions we have ever had to face as a species. And that's the thought I really want to leave you with. When our very perception of the world is being mediated by a computer chip, who controls the software? Who owns the data stream coming from your own brain? And what does it even mean to be human when the reality we experience can just be written in code? This isn't science fiction anymore. This is the next great human frontier.
Thanks for watching. Before your Wi-Fi drops, hit that like, share, and subscribe button. Stay sharp, stay curious, and keep guarding the trends.